most banks don't give you, they don't usually give interest that way. I think I talked about my account, and mine does monthly, which is how many times a year? 12 times a year. So let me just explain to you how interest works, okay? What the bank does, if they, we'll use monthly, because that's what I know. Let's use an easy number. So let's say my bank, this would be way too high, they'd never give me this money. But let's say they gave me 12% interest for the year, okay? What they do is if they give it to me monthly, they don't give me 12% every month. They take that 12% and they break it up. Well, if I had 12% for the whole year, how much should I get per month then? 1%. They take that percentage and they divide it by when they're giving you their interest. Some banks give it to you quarterly. That's 4 times a year. So then they would take that interest and they divide it by 4. So you're going to see this divided by n here. All that is because they're breaking that interest into the category that you get it. Let's say you do get interest once a year, then they don't divide it. You just get it at the end of the year. Okay, all right, so here are the ways that you might see it. This is called compounding it. Once a year or annually would mean that n is once. You get it once a year. Quarterly means you would get it, I said that, 4 times a year, so every 3 months. Monthly would mean you get it daily. Yeah, how many days are there in a year? 365. Okay, unless it's a leap year. Constantly. What's going on with N right now? It's getting higher, right? Constantly, I wouldn't say this. I would say N approaches infinity. We can't do constantly because we couldn't put infinity into an equation. But basically, N would get really, really large. Like maybe instead of daily, I would say, hey, how about twice a day? Or what if it was every minute? Okay. We actually have this thing that in math called E. Have you heard of pi before? You know pi is 3.14? Yeah, there's something called E. E is called Euler's number. It's named after a guy whose name is spelled like this. You don't have to write this down. I'm just writing it down. E is Euler's number, and E is what happens if you put this infinity in for n. Essentially, this goes to this thing called E. It's 2.7-ish. Just kind of store that away for when you take Algebra 2. All right. What do these things stand for? A is going to be the amount after a certain time period. So A is amount after T, we'll say years. What's P?
What's P?
What is P?
P is like, are you P or not P?
Where is this? Where is this in the exponential formula? In the spot where we normally put what? A, good. Who said A?
Me.
Okay.
My y-intercept?
Yes. Yeah, it is your y-intercept. P is called the principal, and principal is not like a Mr. Holden principle. There's this word that's called principal. Principal. And principal is the beginning amount of a loan, or it's the initial amount. What do you think R stands for? Your rate, your interest rate. Make sure you write it as a decimal just like before. And we're going to pick N.
I think I have a paper here that I should have had.
Oh. Yep. And we pick by the compounding period. So number of times compounded. Compounded. And if you're ever unsure of that, you ask me that. If you're like, hey, I don't What's monthly? I'll tell you, that's 12 times a year. Okay, so we're gonna put our things in our formula, and then I'm gonna show you our calculator rules, okay, so that we can put them all in our calculator correctly. Suppose your parents deposited $1,500 in an account. That's your principal. That's your initial value. Paying 3.5% interest. What letter is that?
Your, rate.
R. Yeah, our rate. Compounded annually. What's N? 1. Once a year. Write an equation for the problem and find the balance after 18 years. Okay. So I write A equals, right here, I'm going to put my principal, that's 1,500. And then I'm going to put this in a parentheses. 1 plus, I'm just following here, my rate is 0.035 divided by, you said N was what? Once a year. And then once per year. So 1 times T. Now, and hopefully you guys know that when you multiply or divide by 1, what happens? It stays the same. So you can put it in if you want, because when it's not 1, you're going to need it there, but it does stay the same. All right, you guys have your calculator. I'm going to use the same type, I think. How do we type this in? Okay, I wanted to do 18 years, right? So I do 18 for T. So we're going to type in 1,500. We're going to use a parentheses. We're going to actually do 1 plus 0.035. I'm going to do divided by 1. Do I really need to do that? No, but remember I'm doing that just to kind of in my memory when it changes. I close the parentheses. And then figure out the exponent. What's 1 times 18?
18.
So I'm going to raise it to the 18th power. Did you get the same thing as I got? That's our goal right now. Okay. Yay.
Can you do the other side so I can see how you did the T part earlier? Or you used to do that?
I don't think I can do that anymore. But
Oh, because 18 years time.
I just did a caret and then the 18 here. Oh, I did do that. Here, look, I can do that, I think. There. Okay. You guys tell me in part B, what is the one letter that's going to change? Everything stays the same except for... Yes. Okay. That affects the N. The N shows up here and here. It shows up in 2 spots. So what I'm going to do is I'm going to change. Here's why. Because if you get interest 4 times a year, you get it 4 times a year for 18 years. You have to do 4 times 18 because this represents how many times you get your interest.
Wait, isn't the N where parentheses too?
Okay, so it goes down here. So I'm going to divide my interest by 4 because I get it 4 times a year, a little bit every 3 months. And up here, it's going to be 4 times T. Okay. Now, you're going to have to do 4 times T for me, though. What is 4 times T? What's 4 times 18? Okay. So what I'm going to make sure that I put 72 in for my exponent now. Okay, let's type it in just like we see it. So 1,500. We do a parentheses. 1 plus 0.035 divided by 4. I close my parentheses. You with me so far? Am I going too fast? And then, what are we going to put here? 72. Which check that you get the same thing I do. Okay, why do I get a little more than last time? Because I got my interest 4 times a year, Anthony. So guess what? After the first 3 months, they took a little bit of interest. It wasn't all that much, but they put it in my account, and now I have a little more money that earns interest. So the more times you compound it, the more money you get. 280871. Okay, do you guys think you could try the last one on your own or not?
Yes.
What are you going to put in for n this time?
12.
Okay. I'm going to set it up, and then I'm going to let you put it in your calculator, and then we'll check. Let's see. 12 times 18. That's 216 times. It's right here. Anthony, did you get the same thing I got? Did you get that? Cool. Salvador, you too? Did anyone not get the same thing we got? Okay. All right. Last thing we're going to talk about then today is something called a half-life. Okay, this is kind of a science thing. Who likes science? What? So, you're not probably studying it, maybe you are, if you're doing some environmental stuff in science. I don't know if you do that in 9th grade science. But this is also a biology thing, so when you have biology, you might talk about something called a half-life. A half-life, in math we don't make up really like fancy names for things. A half-life is how long it takes for something to decay. That's it. So for instance, let's say I said a banana's half-life is 30 days. That means if, I don't know what a banana's half-life is. That means if you had a banana and it was sitting out in the ground in your yard for 30 days, after 30 days, half of it will have disintegrated into the ground. That's what that means. Okay. So half-lives are also used when you take medication. You do not have to share, but you know, if you take a medication and they said the half-life is 10 hours, that means in 10 hours, half of the substance has left basically your bloodstream. So if something is a long-term release, like if you maybe have a medication that for ADHD and you want it to last a long time, you want it to have a bigger half-life because you want it to be acting in your body for longer. Okay, so half-life is how long it takes for half of something to go away. So do you remember how we had to mess around with exponents before? I don't know if you remember that last week, beginning of this week. when you're doing a half-life problem, first of all, the multiplier is always 1/2. I hope that makes sense. But we have to figure out how long it takes for something to get to be half. So what we do is we take the exponent and we divide it by its half-life. Okay. Now be careful in these problems. Sometimes medicine has numbers in it, and the numbers have nothing to do with the problem. It's just the name of the medication or the substance, okay? All right, let's see if we can figure this one out. We should tell, what's A? What's A always been? Initial amount. HL is what I tell you the half-life is. It's going to be a number, half-life. Okay. T is going to be what you put in there. All right, so for instance, this substance right here started at 100. What's its half-life?
50.
Well, no, 50 is the amount. When does it reach 50? 6.5. Its half-life is 6.5, whatever this is. Maybe it's hours or something like that. All right, the half-life of a radioactive substance is the length of time for half the substance to decay into another substance. To treat some forms of cancer, doctors use radioactive iodine. The half-life of iodine 131 is 8 days. Can somebody identify for me the number that does not matter in the problem? 131. It's the name of the iodine. Don't put 131 anywhere in the problem. But what is important is the half-life is 8 days. Where are we going to put that?
Oh no, for the bottom of the
The HL. Yep. Okay. A patient receives a 12 millicurie treatment. Millicurie is just a measure of volume. Where am I going to put that? For A. So let's write our equation. Y equals 12 times 1/2. If you like 0.5 better, I'm okay with that. But put it in parentheses. To T or X divided by 8. We just use T in this case because X is time. Yeah.
Do you have to put the time?
You want to call, well,
And
if I said a general equation, you'd want T, but you're right. In this case, they ask for what? For time. They ask 16 days later, so if you wanted to go right to that, that's okay. Here's what I would still do, though, just like before. For less error, I would calculate your exponent first. So if I put 16 in for T right here, what is 16 divided by 8? 2, which actually just means that 2 half-lives have happened. Can anyone do this without a calculator? If it got half as big or half as gone twice. That would be once. Good job. 3. Let's show how it confirms on our calculator, okay? So I have my 12. I have my half or 0.5. And we said we're going to calculate our exponent first. 16 divided by 8 was 2. And lo and behold, yes, it is 3. Millicuries.